Yes, sir, you are audible.
Yes, sir.
Okay. Sorry, there was actually some technical problem. We'll start now. Yeah, my screen is visible.
Yes, sir.
Yes.
Okay. So first, I will introduce myself. My name is Parasram Shastri. Actually, total I have 20 years of experience in the construction industry. So near about 10 to 12 years of experience in the construction management and rest of the experience in the structural engineering. So in our course, we have purposely introduced this contouring session because when we are designing the foundation, that time we should be in a position to read the contour plan properly. So the basics of the contours that we must know. Otherwise, there may be big problems that can happen when we are designing our foundations. So many times people don't refer contour plan and the mistakes happen. Therefore, we will see what is the importance of the contour plan. So first, we will see the basics of the leveling, because when the contour plan is prepared, first we have to plot all the levels in a grid, and then we can draw the contour map. Okay, so we will see the basics of the leveling. Okay, so leveling can be done with two basic equipments. First is the level tube and second is auto level. Okay, so first we will go what is the level tube, that we will see. So actually the level tube is a very simple instrument, we can say, that is used for the measuring the levels of small area. Okay, for example, if the area is small, say I will draw one picture. So this is the wall and this one is the window. Okay, if a mason want to make sure that whether the sea level of the window is at the same level, what he do, he uses the level tube. So what is the principle of the level tube? You will put the level tube like this. Okay, so what is the principle of the level tube? There is a water inside the level tube. Okay, so water is always at same level. So inside water is filled. For example, this blue color, it represents the water inside the level tube. Okay, so water level is at the same horizontal plane. Okay, so from this we can find that this particular sea level is at same level. Okay, if there is any error in the sea level, then we will immediately come to know what is the error. For example, sea level is constructed like this. So you will come to know that there is this much difference is created. Now, the basic principle is that you have to first create a perfect horizontal plane, and from there you have to measure the distances of different objects. As this reference line is in perfect line, you will come to know whether there is any undulation in the floor or it is in a perfect line. So this level tube, this can be used only in a small area, but when the area is very big, that time this won't work, or this will be a very tedious job. So for that, there is another instrument, that is auto level. So the principle of the auto level is same. First, you have to create a perfect horizontal plane. Okay. For example, your ground level is like this. Okay. And now you have to find out the. Hello.
Sir, screen is not visible.
Screen is not visible.
It's not visible, sir. Not.
Your voice is not clear.
Screen is not visible, sir.
Just a minute. I will share again. Now screen is visible.
Yes, yes, sir.
Okay. So previously, whatever I told, that was not at all visible.
Yes, visible, sir. Now visible.
Okay. Sorry, I will explain again. If there is any problem, please let me know, because here it is for me it is difficult whether the screen is visible or not to see check it. Okay. So actually there are two instruments for checking the levels. So the basic equipment is the level pipe. So level pipe is like this. Okay. And it is filled with, say, water. So this is the level of the water. So in this, the water level will always be in a perfect horizontal plane. Okay. For example, there is some surface like this. Okay. And we have to check whether this is perfect level or not. Then what we do? We will mark these levels on the wall, and from there, with the help of the measuring tape, we will measure the distances. If this distance, say 2 meter, okay, and this distance is 2.1 meter, that means this is not in a perfect level and it has a slope of 0.1 meter towards this. Okay, or this, if you measure this distance, it may be 2.2. So there is undulation at this particular point. So the property of the water is it will always remain in a horizontal level, and we make use of that property. Okay, but this level tube that you can use only in a small areas. Okay, when the area is big, what we use auto level. For example, your ground level is like this. Okay, and now you have to find the levels of various points. For example, this point, this point, this point, and this point. So the auto level principle says that you have to create one visionary imaginary plane perfectly, which is perfectly horizontal. Okay, so how we do that? For example, we set our equipment, that is auto level, at this particular point. And here, after leveling and all the setting of this equipment, this level is perfectly horizontal. We see from this end, okay, and as this is perfectly leveled, whatever you see, that will be in one horizontal plane, and we use the staff over here. And we measure this reading. Okay, so to find out the level, or we can say reduced level RL of this particular point, what is important? Important is that you should have one benchmark. Okay, maybe temporary benchmark. So suppose you have a temporary benchmark at this particular point. Okay, and I will consider this RL as 100, RL of the benchmark as 100. So from this reference level, what I will do, I will measure the elevation of different points. Okay, say 1, 2, 3, 4, 5. Right? So how we are going to measure that? So first I will find out what is the height of this particular imaginary plane above this. Okay, so that means if I extend this line over here, I will measure this distance first. Okay, vision line is how much above the benchmark. So for that, what I will do, I will put my staff on this benchmark. Okay, and I will see from this. For example, here I am getting 1.23 meter reading. Here the zero of the staff. That means this distance is 1.23. So automatically the reduced level of this imaginary plane is this 100 plus the reading of the staff on the benchmark, that we call as a backside reading. 1.23. So RL of imaginary plane is equal to 101.23 meter. But this imaginary plane that we call as height of instrument, HI. Okay, so first what we did, we fixed the reduced level of the imaginary plane. Okay, and from there now we will measure the different points. For example, one point is here. I will put my staff here. Okay, I will measure this reading. For example, this reading is say 0.6. Everything I am telling in meter. Okay, so 0.6. Now you know that this is the height of instrument 101.23. From that I will deduct 0.6 so that I will get the RL of this point. Okay, so from height of instrument, if I deduct 0.6, then I will get the RL of this one. Okay, similarly I will find out the RL of different points. Okay, so we have one standard table for recording all these readings. Okay, I will show that. The screen is visible?
Yes,
Hello?
sir.
Okay. I changed the screen, that's why I asked you. Here you can see this is back side. Okay, then intermediate side, then foresight. Back side, just now we saw that when we put a staff on the benchmark, whatever reading that we are getting, that is the backside reading. Okay, and this RL 100, it is assumed. Okay, the RL of the benchmark, that is 100. So to find out the height of instrument, here what will be the reading? Height of instrument 100 plus
101.8.
1.8, right? 100 plus 1.8, so 101.8. Okay, from this height of instrument, these are the intermediate readings. So from the height of instrument, if you deduct intermediate readings, we will get the RL of the 0.1, 2, 3, 4, 5, 6, like that. Okay, and you will get the reduced level. Now, change point. So what is this change point? Just a minute. So why that change point is required? See, this particular imaginary line is up to here. If you want to measure the level of this particular point, how you are going to measure? So you have to shift this instrument because the line is going below. So what you will do, maybe you will shift your instrument, say here somewhere. Okay, so when you are shifting the instrument from here to here, the last reading on the staff should not be moved. Okay, the staff should be kept there. Only the equipment that has to be shifted on this side, and you should note down the reading on the staff where you have taken the last reading from this location. Okay, and this location, this reading that you have to note down in the back side. Okay, so what is the principle here? From here you know the reduced level of this particular. Now you know this reading. Okay, you know level this plus the staff reading, you will get height of instrument after shifting to the next point, after shifting to the next point. Okay. So here in the remark, we can write change point so that we will come to know that at this particular point, we have shifted our instrument. So again, the same process that you have to repeat, you received the new height of instrument. From that height of instrument, again, whatever the readings are coming, that you have to deduct and you will get the array. So this is the process of getting the reduced level of different points. After that, what we are supposed to do? We are supposed to prepare the grid on the paper. Okay, the area that you have covered, that area has to be divided in a grid, and you can write down the numbers. Like here we have mentioned 0, 1, 2, 3, 4, like that. Okay, and you have to note down whatever the readings that you have taken. Actually, that reading has to be taken at the junction only. So I have not shown in the sketch, but before taking the readings on the ground, you have to fix these points. Say, for example, you have prepared the grid of say 5 meter by 5 meter or 2 meter by 2 meter. Anything, how accurate you want the contour, it depends on that, how much grid you should take. Okay, so after writing all these readings, then your next step is drawing the contour lines. So how you are going to write the contour lines? See, whatever the reading that you are getting, that will be in decimals. It will not be a whole number. So 95, 98, 98.1, 101.2. Okay, but the contour, it has a specific interval. Like here you can see one example is given 89. So 89 meter contour is prepared. Okay, so but 89, where the 89 will come? 89 will come between, if you consider this A, B. So somewhere here, this is 88.42. So 89 will be somewhere over here because this point is 90.89. Okay, so your point will be somewhere here. So you can mark it over here. Similarly, on this grid, this is 88.42 and this is 90. Okay, so your point will be somewhere here. So you can mark here. And now you can join the line, right? So just now I told you this is the approximate method. Accurately, what you should do, you should do the interpolation. Interpolation means like this. Okay, your 89 point is here. So from point A, how much distance I should take for the point 89? That we are supposed to calculate. Or from A to H, how much distance from A towards H the point 89 lies? So how that can be calculated? One example is given here. Interpolation. So here 88.42 point is marked. Next point at B is 90.89 is marked. Okay, first we have to find out what is the difference between these two. Okay, so that calculated 90.895 minus 88.42 is equal to 2.475. Okay, now I don't know where that particular 89 point will be there, so I have marked it as a X. That I have to find out. And here the level is 89. Okay, again this distance we can calculate 89 minus this, so it will be 0.58. So by applying similar triangle, 0.58 divided by X is equal to 2.475 divided by 5, you will get the distance x. Here in this case it is 1.17 from point A. Okay, so that you can mark. You can mark here, and similarly the same rule you can apply for this. After this 89, so next contour interval that you can decide. Either you can take 89.5, you can take 90, you can take 91.5, whatever it is. Okay, and same process you have to follow. For example, you have taken 90.5. So again 90.5 will be somewhere here in this direction. It will be somewhere here, and like that you can connect the contour plan. Okay, this is one example. This one is the second one. So have you any doubt in this? Okay, no doubt. We'll proceed further. So these are the definition. Contours are the imaginary lines on the ground joining the points of equal elevation or reduced levels. This is the plan, and this is the actual section, you can say. Okay, here you see the outer ring, the elevation is 2000 meter, whereas inner one is the 1000 meter, and its elevation is like this. Do you find any discrepancy in this, or it is right? $2,000 is higher than 1000, isn't it? But here 2000 is below. Actually here it is minus. This 2000 is minus 2000, and this is minus 1000. Okay, so 2000 is minus, that's why it is below here, and 1000 is above, that's why it is here. There is one small mistake in this sketch. So if you find the contour plan like this, you should be in a position to imagine how the ground profile is. The ground profile is like this. Okay, so there are different patterns of the contours, and if you want to read the contour plan, you should understand what is the meaning of different lines, different patterns, and how it is significant for us while we are designing our foundations. Okay, so we'll see some patterns here. So there are some terminology, that is the vertical distance between successive contours is known as a contour interval. Just now we saw that either you can go for 89 contour, then 89.5 contour. So the distance between these two, 89 and 89.5, is contour interval. Okay, we can say here it is 103 and here it is 104. So contour interval is 1 meter. 104 minus 103, that is 1. Okay, here some guidelines are given how much the contour interval should be taken. 0.2 to 0.5 sometimes 0.5 to 2 meter, then 2 meter to 3 meter. So for structural engineer, this all is ready-made available. Just we have to read the plan and we have to interpret the ground profile. That was the vertical distance, contour interval, and the horizontal distance between two contours, that is called as a horizontal equivalent. Okay, Can you tell me what is the contour interval here in this particular sketch?
1 meter.
Yes, 1 meter. Good. So 98. Generally, the contour interval, generally most of the time, maximum, it has to be same. 97, 98, 99, 100. So there is a 1 meter contour interval. It should not happen that one contour is at 97, second is at 100, third one is at 101, fourth one is 105. Not like that. Otherwise, you cannot read it properly. Okay. So contour interval has to be same. Yeah. Now you see, there are two patterns in this particular sketch. One is gentle slope and second one is steep slope. So what do you observe in these two? When we can say gentle slope and when we can say a steep slope? The lines, you see the lines of the spacing between this contour interval is more. That means the slope is gentle. If the contour lines are closely spaced, then we can conclude that it has very steep slope. Okay. See here. Uniform slope. Uniform slope means what? This is uniform slope. This is not a uniform slope. Slope is more here. It is less, more, it is less, like this. Okay. So this is a uniform slope. So if you see from the top, the contour lines, the spacing will be equal, perfectly equal. That means it is a uniform slope because this contour interval is always uniform, say 1 meter. Right? And as this is uniform, this horizontal lines has to be equally spaced. Right? So when you see a pattern, like this, contour pattern in the plan, if you see like this, that means it has a uniform slope either in this direction or in this direction. Okay. So this is one section here. In contour plan, you don't have this elevation. You have only the plan and these rings you can see. So from this, you have to imagine how the ground profile is. Okay. You can see at the center, how much is the level? 80, then 75, then 70, 65, 60. So contour interval is 5 meter. And as you go away from the center, it is going to drop 80, 75, 70, 65, 60, like that. That means it's a hill where the peak point is here. So you can find out the section. Okay. For that, what you have to do, you have to take the projections and this elevations 80, you can mark here 80, 75, 70, 65, like this. If the profile is very complex, then you can do this graphically. Okay. Now here exactly opposite of this one. How it is? From the contour plane, you can see at the center the contour is 60, and as you go away from the center 60, 65, 70, 75, 80. That means it's a valley like this. Okay. Here the contour of a cliff. As you go away from the center, there will be different contours 40, 30, 20, 10. That means it is below 10. And as you are moving from right to left, it is rising. And after this, you can see this dotted line. This dotted line represents that below these points are not visible from the top. That's why this projection is taken as dotted line. Okay. So there is a cliff whose slope is like this. Again, from the bottom, it is falling like this. Understood or any doubt? Okay. This is one more example. Here you can see the vertical cliff. Here, what is going to happen? All the contours, they are coming here and merging. 20, yes, elevation 20 is here. 30 also on the same vertical plane. 40 also on the same vertical plane. That's why you can see the contour map. All the contours are merging at one particular single point. That means this particular point has different levels. That means it is a perfectly vertical surface. Okay. Okay, now you understood the pattern of the contour map and how the contour is being drawn, right? Now, what is the significance of this in the foundation design? Before that, I will share one example with you so that you will understand the importance. When I was working in CICEL, that time there was one building and the building was nearly 50-meter . 50-meter, and this was nearly 15 meter. Okay, and there were columns. Sorry, my sketch is not that much good. Actually, I am showing only some of the columns. So, like this, there were columns and beams. that time I was project engineer and I received the drawing from the structural consultant. This was the layout. Okay, because architect, what is our general process? Architect prepared the plan, he sends it to the structural consultant. On the basis of the architect's drawing, he put all the column positions, beam positions and everything. He designed the column. Okay, and this column sizes were 230 by 450. Some columns were 230 by 380. Okay, so now we started our work. Excavation was carried out for the footing. When we went on the site, what we observed, the profile of the site was like this. Understood? The profile of the site was like this, and the level difference from this point to this point was nearly 10 meter. And our building was supposed to rest in a position like this. Everything was in the plan. This elevation nobody noticed. So this was how the building was supposed to place. We came to know that here the column height was 10 meter. Unfortunately, structural consultant and even architect did not go through the contour plan of that particular area. They simply saw the plan, prepared the plan, and they proceed for the work. All this drawing came there. Now you can tell me what will be the problem here. As a structural consultant, what are the challenges you will face? The SBC was nearly 300. So they took the SBC and they just designed the building. So what was the biggest mistake? What may happen if you go with this drawing, if you go with this column sizes, what will happen? Any idea? This I will say a blunder, because your column sizes are 230 by 380, 230 by 450, and you are taking 10 meter height. So definitely for slenderness, the column will fail. Here you need tie at different levels. First. Secondly, you need size of the column to be revised. So this drawing came on the side. After that, this was noticed and the drawing was sent back to the consultant, telling him all the situation, and nearly 1 week was wasted because everything was redesigned. Secondly, this was a ground structure. Okay, so as it was a ground structure, they had given some brick masonry around the periphery, and they had suggested the backfilling inside, as generally we give 2 feet or 3 feet, 0.6 or something. Okay, but here the situation is totally different. Can we go for the retaining wall? Either you can go for this, okay, you can keep this space open for the use, or around the periphery you can go for the retaining wall. So around the periphery, you have to construct the retaining wall, okay, then you have to fill inside, and then you can take the grade slab and proceed further. But here we decided not to go for this because the cost of the project will be too much. 10-meter high retaining wall, it will be too much heavy and it will be very much costly. That's why we prefer to go for the columns with the tie, and one additional slab had to be considered. The suspended slab had to be considered at this particular level. And we went further. So now you come to know that what the biggest mistake can happen if you not considering the contours of that particular area. If it is a very small building, say 10 meter by 5 meter, 6 meter, generally there is not much variation, but you should also see where your project is. In the hilly area, even in the small length, there is a big level difference. And this particular project that I'm talking about, it was situated in the hilly area. Okay, so this building was on the slope of the hill. So special attention has to be given whenever your project is in the hilly area. Okay, so this is one of the live example. Now, have you any doubt, any question in this? No. Okay. We will see one drawing also, contour plan. Screen is visible?
Yes, sir.
Okay. So this is one of the contour map. So practically how we will read. Now you will tell me where is the steep slope. This is the contour map, and your building is supposed to rest in this particular zone. And this white line you can see, this is the compound line. This one. Okay, this is the boundary of the project. So can anyone tell me where is the steep slope? Below, left side, right side, or on the top? अरे नहीं समझा. स्टीप स्लोप कहां पर है? कंटूर मैप दिया है अभी तुम्हारे सामने. ओके, नाउ यू हैव टू टेल मी just by observing the contour map, where is the steep slope and where is the mild slope? अरे भगवान, अरे अभी तो बताया.
Bottom, sir.
यस, करेक्ट, वेरी गुड. ऐसा कुछ बोलो तभी मुझे समझेगा कि तुमको कुछ समझ में आ रहा है बोल के, राइट? सो as we studied, if the contour interval is same, then the closely spaced lines indicates there is a steep slope, and if the spacing between the two lines is more as compared to this, that means it is a mild slope. Okay, here a little bit steep, here more steeper, and here a little bit mild. So this reading is important because you will come to know, अरे भाई जिधर ये प्रोजेक्ट अपना बिल्डिंग यहाँ पर डालना है नहीं डालना है, okay, here there is a steep slope, so there will be a problem for foundation in this particular area. So what we will do, we will just move the building or whatever the structure is there to this particular area or in this area, as this area is more flat as compared to this one, because in the sloping area the cost will be much more, the time of construction will be more, okay, and unnecessary, we should not waste our money. That's why this has to be studied before finalizing the layout. Okay, now this is okay, fine, you understood from this direction there is a steep slope, from this direction there is a mild slope, you understood this one. Now my question is, if you take the section like this along this line, okay, and you are supposed to draw the elevation, how you are going to draw? Because for example your compound wall is lying like this, so you should draw the section and you should see how the levels are playing the role in the construction of the boundary wall. So that example is here. Architect has already drawn the contour here. You can see this red line, this is the natural ground level, and there are actually two levels. One is natural ground level and second one is the finished ground level, that architect decides which should be the finished ground level. Here you can see this is the finished level, okay, and this red line, it is the natural ground level. So if you draw well before on the plan in the drawing, then you will come to know ki, okay, the natural ground level is like this. If I place my finished level this way, there will be this much cutting and this much filling. So well before, I will come to know what will be the cost for the cutting and what will be the cost for the filling. Okay, there, for that you should draw this plan. Now how to draw this? Here you can see 96.6, 96.996. So these are the points of the, I will say levels of the points. Okay, these are the points and this is nothing but levels of the points. So 96.6, from there what I did, I draw the line here, that is the zero level. Okay, so this is the zero level. Now I am supposed to draw the different lines. Here you can see my compound wall is cutting here 99.78, here it is cutting 100.047, here it is cutting 100.305. So I will get different levels of different points. Okay, that I have written over here. First what I will do, I will write all the levels. Okay, now I am supposed to draw the profile. So what I will do, I will mark my zero level here. Okay, then from here I will draw the offset 99.742. okay, from here I will put offset of 99.742, so it will exactly match here. Similarly, for this point, I will put all the offsets of these measurements. Okay, and then I will connect and you will get a fine ground profile, and further you can plan your retaining wall, your compound wall, or whatever it is. Okay, now here you can see, if you don't draw these sections of the ground profile, you will not come to know that there is 2.5 meter earth filling is coming, because your finished level is here, that architects has already mentioned. And if you draw the natural profile and finished line, you will come to know 2.585 is the filling, and that filling can be sustained by or retained by only RCC wall. So you cannot plan any brick masonry or RR masonry over here. You can do that, but for that you have to go through the designs. Okay. And from this profile, you can design your RCC wall, and then on that, you can plan for your compound wall. So like this, see here, your natural ground level is above and your compound wall is below. Here you come to know this much excavation, yeah, that you have to do. At some point, it may happen that that particular area is, the elevation is high as compared to the other areas, then you have to go for the cutting. But everything you should understand well before you start your project. Okay. So any doubt in this?
No, sir.
Okay. Same one more contour plan here. By looking at the plan itself, you will come to know first I will see this is 97. So the contour of this is 97. Then here 97.5. Then 98. So how much is the contour interval? 98, 97.5, 97. So contour interval is how much? 0.5 meter. Okay. So only the level difference is only 0.5 meter, and the gap between two lines is too much. That means it is nearly flat area. You see, you cannot see even a small area where it is closely spaced. Only in this portion, you can find there is a steep slope or a hill type area is there. Okay. Now this is the last drawing. Okay. Now let me check how much you understood. Is drawing clearly visible to you?
Yes, sir.
Okay. Now here the levels are given 190 and here it is 185. Okay. And between these two contours there are 1, 2, 3, 4 and 5. So 5 lines are there. So can you tell me which side slope is there, from here to here or here to here? Or there may be some other patterns that can be observed from these contours. We are talking about this area. Okay. So area is this side, or I will say this side as the north side and downward side as the south side. So can you predict which side the slope is? Towards north side or towards south side? Not clear?
North side, sir.
slope is towards north side. Okay. Anyone has different answer? Okay. From this, generally the slope should be towards the north side, but not necessarily towards the north side. There may be other options also. Like this is 85, okay? Then this is yes, there will be only one option. There won't be any other chances. The slope will be towards north side only. Yes, that is right. Now, yeah, from here, when I'm going from west side to the east side, like 185 to this side, okay? So here 185, here 185. So what may be the profile that is in between? Will it be flat or there will be some other pattern you can observe? No, no guys. There are two chances. It cannot be flat first. Why? Because already some contours are shown in this particular area. Okay. If it is exactly flat, then your contour should start here and here. There should not be any contour in between. So what are the chances? Either it is a hill or it is a valley. Okay. Either it will go down, then it will come up again here, or it will go up and then come down. So 185 here and 185 here. Between these, contours are shown. That means it is not flat. Either it is like this, right? Therefore, the contour of this point, this point, this point, this point are shown. The value is not given. The value of these contours is not given. Therefore, we cannot conclude. Or the second option is, it may be like this. Only end-to-end contours are given and intermediate contours are shown, but the values are not given. Okay. That means for each and every contour line, the value should be assigned. Then only we can conclude 100%. Okay. Now here, from this 190 to 195, actually here contour interval is 1, because you can see here 185 to 190, 5 lines are there. That means contour interval is 1 meter. The same way here 190 to 195, but there are many contour lines. What does it mean? Nearly 10, 12, 10 contour lines are there. What does it mean?
So steep slopes.
What? Steep slope.
Yes, sir.
Yeah, but actually, okay, let it be steep slope. but the number of lines are nearly 10 and the contour interval is only 1 meter. So ideally from 190 to 195 there should be 5 lines, but there are more lines here. So what does it indicate? Any judgment? Here it is 195. Okay. Here also it is 190. Sorry. What is the value? One 95 and 190. So this is 190 and this is 195. And there are 10 control lines. Either it is going here 195, I will write. From here, it has come down in 5 lines here. It has become 190. Okay. And from 190 to this, either it is this way or it may be this way. Okay, that's why these 5 control lines in this zone from here to here and 5 from here to here. So it may be like this or maybe like this. Why we are predicting this? Because the values are not given. If the values are given, then definitely 100% you can draw the profile. So this is how you have to interpret the contour map, contour plan. What does it indicate? This particular? If the loop is there, what does it indicate? Loop, these are, you consider this as a small loop. Or you can see this 185 line is going like this and coming to this 185. इसका क्या मतलब है? लूप का क्या मतलब है बताओ पहले. नहीं पता. लूप का मतलब है either it is hill or it is valley. For example, this level and this level is same nearly, right? If I write this as 185 and this as 185. So in the plan, what you will observe like this 185 or same for the valley. The levels are same, okay, and they are creating one closed loop. So like this. Okay, so from this, either it is a small hill over here or maybe a small pit. Understood? Okay. So anything else? Any doubt in this session?
No, sir.
Okay. So shall we stop here now?
Okay, sir.
Okay. Take care. Good night.
Okay, sir. Good night, sir.